Good morning, everybody. Earth Science kids, we're going to be studying landscapes today. Take a look outside your window. You're seeing a landscape. If you've grown up in this, you kind of get this feel like this is just the way the Earth is. But if you think about it a little bit, everything you see, everything outside is because something happened to it. Rocks don't just disappear, rocks don't just appear. Something happened. In earth science, we get to look at these things and understand them. As you travel around the world a little bit, if you get to, you will see different landscapes everywhere. Even if you just travel in New York State, even if you just travel locally in New York State, you will see different landscapes. Every landscape is there for a reason. So the landscape is the surface of the earth visible from any location. Landscapes are produced by interactions between plate tectonics, climate, and a little bit of human activities in most places. In some places, human activities have a really big role to play. So the characteristics of a landscape can be used to separate each into landscape regions. The characteristics: hill slopes, stream patterns, and soil features. That sounds like a little nitpicky, but you'll see that this makes sense. So the angle of the slopes, the gradients, right? We did that when we looked at how to figure out what the gradient on a topographic map is. So we could easily determine what the gradient is. We can measure it directly or from topo maps. We can use aerial photos. So there's certain stream patterns that give us clues as to what happened. They're identified by the patterns they make on the land. Drainage basin is the area a stream takes all its water from. And stream drainage patterns. Stream drainage patterns, patterns that formed by the streams in a drainage basin. Look at all those patterns, right? We have the dendritic, radial, rectangular, annular. Great, but look right below them and see what we understand to be the case here, all right? When we look at dendritic, that's just sloping land, and it makes sense. The streams all join together one after another, and they form this dendritic, which means tree-like pattern. You can see it looks like the branches of a tree. Why would something be radial? Well, it's all coming away from a higher point. So if we see radial stream patterns, we know in the center it's higher. Look at the rectangular one. What the heck is up with that? Well, there must be some serious geologic forces at play forcing the streams down into particular patterns. And you can see fault block mountains, the way the mountains have come up with plate tectonics does that. One of the odder ones is the annular. You have a central high peak, so the streams radiate away from that, but it's surrounded by uplifted sedimentary rock areas that force the streams also to be in more of that rectangular pattern. So it's sort of a combination of the radial and rectangular. But you can see this from aerial photos. You can see what the stream drainage patterns look like and infer what's going on. Stream patterns are determined by the type and structure of rock over which the streams are flowing and how long they've been eroding the rock. For example, in the Catskills, we have a dendritic pattern, but we've been eroding the rock for over 200 million years. So the valleys in the Catskills have grown tremendously deep. The patterns on a topo map, easily identified. So soils, we group soils with similar characteristics. Composition of soils, the particle size and shape of soils, the organic content of soils, and then porosity and permeability. We'll be talking a little bit about porosity and permeability. Those are two different words. And how mature a soil is. If you dig in the ground here, you realize our soil is not mature at all. We have silly little children's soil. Well, the reason, the glacier dropped all the soil 10,000 years ago, and we've had time to make one layer on top, the A layer. And after that, the other layers really are not in good shape. So landscapes are the surface features of the earth. Landscapes may be three kinds of landscapes, and this is really easy. If you look at these pictures, you kind of got the whole idea. Mountains, plateaus, and plains. Let's talk about the Catskills. Initially, you might have this feel that we're the Catskill Mountains because you've always heard people say, "Oh, we're coming up to the Catskill Mountains," or "You live in the Catskill Mountains." Well, the surface might look like what you're seeing here, but take a look at the underlying bedrock. Every place you're in the Catskills, we've talked about this before, the bedrock is flat, absolutely flat, 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 flat. So could the Catskills really be qualified to be mountains? They are not. Catskills, rather, is a plateau. The Catskill were lifted straight up about a mile into the air through a tectonic collision. They were lifted way up in the air. Well, if you think about it, that's going to make streams run faster. They'll get more water from the sky a mile in the air. They'll squeeze more stuff out of it. The streams will run faster. They'll cut deeper. If you stand at the top of a Catskill mountain and you look down, a mind-blowing realization is that when you're standing at the top of the Catskill Mountains and you're looking down into the valleys, all of that stuff was once there. You used to be able to walk without going downhill from one Catskill mountain to another, to another, to another, because they're not mountains. It's a plateau, all raised, and then the valleys were cut out of it. So it'd be more appropriate to call us the Catskill Valleys. The mountains never existed. It was a plateau. So what does it take to be a real mountain? Well, if you look at the underlying bedrock structure in a real mountain, the bedrock is a mess. It's all twisted, folded, spindled, mutilated, messed with, seriously crunched bedrock. Everywhere you go, you're seeing these tilted bedrock features. That's not what we have in the Catskills. So in order for something to be classified as a mountain, yeah, it has to look all mountainous, but the bedrock itself, you have to take a look at that. Every time you go through a road cut, look at that. Is it a mountain? Okay, the bedrock will tell you. Catskills are a plateau, so what about a plain? How can you tell something is a plain? Well, first of all, it's flat, really flat. And when you see a rock cut, well, that's the funny thing. You really don't see a rock cut. If you're in New Jersey, do you need to really cut through rock to make roads? You really don't. It's so flat pretty much every place. You could just go with the topography. It's very rare you're ever going to see a rock cut there. But a plain landscape has been either not tectonically lifted or has been cut and for erosive reasons just smoothed out. So mountains have distorted bedrock structure and mountains. Plateaus might have mountainy looking things, but the bedrock structure is flat. Plains don't have mountain structure-y things at all. So mountains have a large relief between the highest peaks and the deepest valleys. What does that mean? Relief is the elevation change in an area. So if you start at 2,000 feet and end at 3,000 feet, the relief is 1,000 feet. If you start at sea level and end at 3,000 feet, the relief is 3,000 feet. Okay, so it's the difference between the high and the low. In mountains, streams erode very quickly. Now, why? Well, because they're steep. They run fast. They can carry big chunks. They carve deep valleys. Much of the land is very, very steep. It's not really good for building houses on, not really good for industry. A lot of mountains are not very populated at all. Although humans are amazing at where they can live, and there are places where you have serious mountain communities of people who are quite used to living in the mountains. Well, this would be a satellite photo, and you could tell at the top of the picture it's flat. And you right away then get into, yes, those are mountains, seriously folded and messed with rock. And you can see how deep the valleys are there. Okay, what kind of bedrock are you looking at? Seriously folded bedrock. That really does make sense, doesn't it? Whoa, there's a mountain, right? This is Mount McKinley or Denali, the highest mountain in North America. And you can see the mountains in the foreground. Those are serious mountains. But that thing behind it, whoa, that's a mountain. right? Let's talk plateaus. Plateaus are relatively flat or rolling uplands where streams have cut deep valleys. That's the Catskills. They're often made of flat beds of sedimentary rock which have been raised. Again, the Catskills. One of the magic things about the Catskills is in the valleys. Mountains are always cool to be on top of, and absolutely climb to the top of a mountain, sit down, enjoy the world. But the valleys in the Catskills, they have been cut very deep, and they're amazing places to go. They have less relief, distance between the high and low, than the mountains, but of course, more than plains. Well, look at that. If you're looking up and it's all flat bedrock, that bedrock must have been raised as one unit up into the air. That's a plateau. There's an odd looking aspect of a plateau. So plains, generally flat and low in elevation. Think like Kansas. They have few small hills, but very little relief, very little difference between the high and the low. Florida, the Midwest would be good examples. In Florida, what's the highest point you could see? A tree, a big tree, a couple 100 feet away. That's it. Or if you're at Walt Disney, one of their pretend mountains. That's it in Florida. Maybe a garbage dump. What kind of place do we have here? This is the VLA. It's called the Very Large Array. It's a space radio telescope. For years, it reigned as one of the very best radio telescopes in the world. Still is absolutely excellent. We get a lot of scientific data from this. But that's not the point. Look around it. Where is it? Okay, you see a mountain in the distance, but what about all the land around it? This is what a plain is. For us mountain people, when we go to places that are pure plains, it kind of messes with us a little bit. I know I go someplace like that, and I long to see a mountain in the distance, and the flatness kind of is bothersome almost. Ha! Look at that. Would be in the Midwest, but something also odd. You see a fault line cutting right through this farmer's field. I've used that picture before, but that would be an example of a plain. What do we have here? Well, in the foreground, we have a plain, and in the background, a mountain. Excellent. So here is a map of the United States with all its major landscape regions. And if we look on the coast, we have a lot of mountains inland from the coast. But if you look right along the coast, we have what would be the coastal plain. It's been eroded over long periods of time and is very flat there. So we have a lot of plain areas here. We have a few like uplands here, but man, the interior is just this huge plain. If you drive across the country, when you leave the Appalachian Plateau at the end of Pennsylvania, for us mostly, we get into a flat region which is surprisingly flat. Roads can just go straight for long, long periods. Finally, you're going across the plains, and you see these amazing mountains start in again. And to see the Rocky Mountains start in when you're on the plains, you don't even see the little points on the, like, rising up above. The haze seems to block it until you're close enough that you suddenly go, whoa, those are mountains. Pretty neat. All right, so we have a lot of landscape regions in the United States. Can we name the landscape regions? Well, start with the easy ones. Oh, wait, they're all easy. How about that? So if we look then at right here, yeah, mountains. Okay, how about right here? Plains. And what do we have here? Well, the leftover one. We have flat sedimentary beds lifted up high. That must be a plateau. So climate is going to have a huge effect on a landscape. So we'll talk first about what a moist climate looks like. In a moist climate, the landscapes are generally rounded. Now, why would that be? Well, we have mature soils, which can grow plant life very well, and we have enough water to make plant life abundant. The soil then is filled with roots of plants from all over the land, and there's no soil exposed, or very rarely any soil exposed to erode easily. So erosion doesn't happen so well. It makes the landscape rounded. The streams are permanent, meaning even if it's dry, they keep running. In general, with a moist climate, chemical weathering is going to work extremely well to change the landscape. Arid means dry, so a climate that is arid. What's that going to look like? Well, landscapes are generally angular and steep. The soil erodes very easily, simply because there's no or very little plant life to hold it. Wherever plants are, they hold on to the soil, but if it's dry enough, you can only support a plant every so often. So much of the soil is just empty, and water and wind, when it does rain or when it does blow, will take that stuff away. There's very little chemical weathering because it requires water to work, so it's mostly physical weathering. Frost action and abrasion by wind would be mostly what can happen to break the rock down there. The stream erosion is rapid. Now, why should that be? Well, when it does rain, it rains very often from thunderstorms, so you get a lot of rain. And is there soil covered with plant life to absorb that rain? No. The rain just runs off, gets into the streams, and the streams then are powerhouses. They have these torrents of water, flash floods that cut the streams very deep. So the streams are very often steep-sided, deep canyons. And there would be kind of the difference. Humid landscapes make the landscape smooth compared to an arid climate. Notice the bedrock underneath both of these features, the bedrock is the same. Look at that. The bedrock is exactly the same, but because one is moist, one is arid, makes all the difference in what the landscape looks like. So under the Catskills, we see horizontal bedrock. Do the Catskills have a humid or arid climate? Look at the rounded mountains. Humid. Excellent answer. Grand Canyon is also part of a plateau. So let us draw the horizontal structure of the rock, shall we? Well, look at this horizontal rock structure here. Let's not make me draw. All right. So the rock structure is all flat. Oh, Grand Canyon. Is that a mountainous area? No, obviously a plateau. And so it's a plateau very much like the Catskills. The bedrock structure underneath it is very like the Catskills. Why does it look so different? Well, is there plant life holding on to the stuff in the Grand Canyon? Not much. So you have rapid stream erosion. That would be an arid climate. And with rapid stream erosion, you can make things like canyons. So here's the map of the New York State landscape regions. Find that map in your Earth Science reference table and answer the question. What landscape region is found at 43 north latitude and 75 west longitude? So you have to look at the map just below that on your reference tables. You have these two maps, okay? These two maps. The one on the lower part will be used to find the latitude and longitude. The one on the upper part, you have to compare to the lower part to figure out which latitude and longitude location you are at. Now, if you look at 43 north and 75 west, it ends you on a particular river. Look close. What is the name of that river? Then if you look back at your landscape map, look for the name of that river. And that will help you determine it. Because when landscape regions are very close, you're going to need some clue as to what it is you're talking about. So looking at that will really help you. So New York State landscape regions, well, if you look at the map on your reference tables of the New York State landscape regions, first of all, note that the Catskills really are a plateau. Note that the Adirondacks are true mountains with metamorphic rocks. When you're in the Adirondacks, yes, huge relief. Some of those mountains you can see from the road are amazing. They will take your breath away if you've never been up there into the Adirondacks. But when you're standing there or when you're going through the rock cuts, you can see, if you see any beds at all, you can see the rocks are all twisted and turned and spindled and really messed with. That's the Adirondacks. And when you reach down and pick up a rock in the core of the Adirondacks, you're going to see a very different rock than you've ever picked up around here before. almost always you're going to be picking up a metamorphic rock, sometimes a very deeply metamorphic rock. Pretty amazing stuff. The other thing to understand about all of New York State is it was completely covered by about a mile thick sheet of ice that was moving and ground the surface of New York State heavily, changed all of New York State, left some really interesting features that, if you simply pay attention, you can see all over the place. Let's talk about oceans for a minute because the shorelines are also an important landscape region. And some of you, I'm sure, love the ocean shoreline. It becomes more interesting when you know a little bit about what's going on. Okay, ocean covered 71% of the planet. That's a lot of the planet. Where the land meets the ocean, things happen. Waves create these longshore currents that move sand along the beach. These longshore currents create beaches, spits, and barrier islands. They also create sandbars. So all this stuff is happening. These longshore currents, the sand is sliding up in one direction along the shoreline. It's really kind of powered by wind. If you think about it, if you have a beach and a wave hits the beach, if the wave goes straight up the beach and straight down, it's pretty much going to leave the sand alone. But if the wave hits the beach at an angle, it'll lift sand up the beach, but when the sand falls, it goes straight back down. So diagonally up, straight back down, diagonally up, and that moves sand endlessly, wave after wave along the beach. That's called your longshore current. If those currents should change direction and strength, all these other landscape features can change. So the ocean is a pretty dynamic place. Look at that picture. This gives you an idea of what's happening. All right, these longshore currents, then, you could see they are moving this way. And if you have this longshore current, say, right along the shore, and then it has an opening, that is going to turn inland like you have here. That would be a spit. Okay, Cape Cod is kind of one of those. There's a variety of beautiful landscape features all over the place. These barrier islands are interesting places. If you look at a map of the U.S. and look at the coast on the East Coast, you'll see a lot of barrier islands. They are put there by the longshore currents. You'll also see, if you look closely, there's a whole lot of development along the barrier islands. A lot of people really love living on the barrier islands. I've spent a lot of time on barrier islands. They are fun. On one side, you have the Atlantic Ocean. On the other side, you have the Back Bay, both of which are fascinating places to be. The problem? They're made of sand. They're temporary features, and people have built a lot of stuff on them. Terrible hurricane could really actually affect barrier islands very much because they are temporary features. Another thing people will produce sometimes to capture the sand is something here like a jetty. You just dump rocks from the shoreline outward, get boats and trucks to dump rocks, so you have a big pile of rocks. And if you look, it stops the sand right there. You have a big pile of sand that just piles up. Makes a great beach. The people on the other side of the jetty might be a little sad, though, because you're stealing all their sand. So that's the idea of how this stuff works.